Hey everybody, good afternoon or good morning, depending on where you're at. Welcome to Cassandra Lunch number 25. Today we're going to continue the discussion that we had last week, which was on Cassandra use cases in different parts of the business platform. We'll do a quick review of it. As I said, this is Cassandra use cases. We could talk about that every week until eternity. There's so many different people that use it. But today I wanted to show visuals of Cassandra in action, and luckily there's a lot of examples on the internet that we can look at. Akwi is a co-organizer. Thanks, Akwi, for getting us started on Zoom. Akwi helps with making sure that we get now in remote Meetup land. Akwi is really instrumental in helping us make sure that we do this on time, that we record the video, that we get the content up there for people to see later on. Thanks, Akwi, for all your work. If you're interested in co-organizing, love to have volunteers so that it's more than just us. As a co-organizer, there's a lot of stuff that you end up doing, but really it's about exposure. If you're in the industry, it gets your name out there and then gives you opportunity to speak yourself. We are incubated in the data community DC. It's a diverse community of communities. We're always looking for speakers of different backgrounds. Currently, Data Community DC is made up of Data Community DC itself, which is the master meetup, Data Science DC, Data Visualization, GData DC is new, I think, I'm going to get it wrong, so I'm not going to say it. Data Education, Data Wranglers, which we also organize, Full Stack DC, Nova Data Science, Nova Data Science, Statistical Seminars. Night Owls is a group that used to meet in person at night to work on side hustles, and that was a really nice group. And then SPDC, it'll come to me. There's so many groups. What we cover here, however, is everything related to Cassandra, or I would even say deeper Cassandra wire protocol. So that's not just Cassandra. It could be Cassandra variants like DataStax, Alessandra, Yugabyte, ScyllaDB, Amazon Key Spaces now, I think that's what they call it, Azure Cosmos DB. We even do a demonstration of InstaCluster or Ivan, which are managed service providers. So anything related to Cassandra, and then anything that talks to Cassandra, so Spark, Kafka, Flink, Spring Batch, you name it. If it touches Cassandra in some way or Cassandra protocol in some way, we want to look at it and learn about it. Okay, so we have a couple of new faces. It's not usually in person. What we would have done is everybody would have gotten up and talked to each other, and nowadays it's all remote. So if you're new, we ask you to introduce yourself and just tell us a little bit about yourself, how you work with this technology, what you want to learn or get out of being a part of this meetup. And if you have something to talk about that you could demonstrate or talk about, what would you talk about? So John, you were first. You want to go ahead?
Sure. John Gavilan. I'm the CTO for Bridgepoint Technologies. We are a full-service IT firm in the suburbs of Chicago. We serve the entire Chicagoland. We do have a couple of other out-of-state companies. Our company situation is a little interesting and where Cassandra falls in. We actually serve as a managed services firm for a lot of law firms and nonprofits here in the city and in the suburbs. And we also have a custom development shop, which is where we started with diving into Cassandra. Out of the custom development shop, we developed an application called Digital Work Order. So it's digitalworkorder.com. It is in the App Store and on Google Play. And we started off Digital Work Order with SQL Server. If you go to the website, it's an empty shell. Most of our customers are corporate. We have a lot of that's available to the public, and we do have customers that are signing up. But a lot of our bread and butter is in corporate. We started off with SQL Server, and I ended up not being able to sleep at night. Oh my God, if my SQL Server dies, I'm dead. And I started coming up with, well, what if I create this program that automatically synchronizes my data to another SQL Server? and then in real time or behind the scenes. I know Postgres does a bunch of things. I'm sure there's some SQL Server stuff, and some of you might be thinking, well, why don't I just use SQL Server replication? The problem with SQL Server replication is it's everybody is just waiting around for the main guy to die, and that's just no good. I need it to be up. And the other challenge was we being a managed services firm, we already had several data centers where we host some of our clients. So it's like, okay, so I could just put digital work order in data center 1 and another copy in data center 2. But then data center 1 died, and oh my God, data center 2 doesn't have the right data. So I was stuck with SQL Server. It was great. I could do all sorts of queries, store procedures, functions. Everything's perfect for a business app, except for fault tolerance. So this is where I started looking for alternatives. And us being a Microsoft shop, and SQL Server shop, we were like, which one is the best? We looked at other what do you call this? Big data solutions out there, and Cassandra just stood out mainly because of the fact that it supported SQL, even though it does not support joins, which was kind of like a deal killer for a lot of people. We were like, let's just bite the bullet. Let's install it. Let's see if it works. Let's see how it works. And it does work. And what we ended up doing was we committed every single sin in Cassandra. We did everything that you were not supposed to do. And it was fine until you started racking up records and you started adding more Cassandra nodes, and then you start seeing all of the issues. But we've done it. We've switched over in 2016 or 2016 to 2017. And throughout the years, we've learned practically every lesson that there is to learn as far as how to set up multi-data center Cassandra, how to migrate or transition to Cassandra from a SQL Server or a ANSI SQL development shop, and all of the techniques pretty much that you could think of. I'm sure we haven't thought of everything, but we've definitely tried a whole bunch of stuff as far as how do I make this thing that takes 2 seconds to write in SQL Server work the same way in Cassandra schema. Us like, I keep joking about how we do things in Cassandra. We have a SQL Server guy who's just like, everything SQL Server, everything has to be denormalized or normalized, and if he were to see what we're doing, he would puke right away. It's like, why are you creating 3 tables for just for this one table? And it's just it's very interesting. But I do have to tell you guys, and I'm sure I don't have to reiterate with you with all of you here, because the fact that you're here, I think, is testament to the fact that you guys are all in for Cassandra. Not sure if there's probably some of you who are dabbing your toes in the water to see if it's viable. All of that hardship that we went through is 100% worth it. We actually have a situation right now where our VPN between 2 data centers died overnight, and one of the Cassandra servers in one data center is dead. There's a commit log file that will read. And before it would be a panic event, but now it's just work. We're just like, now we got to rebuild that node. But the nicest thing about it is the clients don't skip a beat. Nobody skips a beat. It's just extra work for somebody, and it's just beautiful. Once you get it set up and running, it's not a set it and forget it, but it's very, very close to it. So that's me. We also have Hussein, who's also from our company. I'll leave it to Hussein to just say a few words. I pretty much talked about the whole thing.
So I'm gonna volunteer you to present on your journey or different parts of your journey in the future, then, because we see this common struggle, right? You guys learned all this stuff, and there's a lot of material out there, and it's great to hear folks that go through that struggle and say, hey, yeah, no regrets. This is exactly what we needed. So awesome. Good to have you here. Hey, Hussein, you want to introduce yourself and just say hi and how you use Cassandra?
Yeah, definitely. My name is Hussein Morbiwala. I've been working with John for many years at Bridgepoint. I've been working on the digital work order platform product line for a couple of years. I was actually with him when we decided to move to the Cassandra database model, and it was definitely something I was very nervous about. I mean, it was a complete overhaul of our whole system. But I mean, all the sweat and tears that we did for probably almost 6 months to a year, I think has definitely paid off in the long run. Yeah, that's basically it about me. I mean, I'm just been a senior developer. Basically been me and John working on the whole digital work order thing. We're hoping to get a little more developers, versed with Cassandra so they can actually help us out, make this platform a lot better than it has been.
Great. Yeah, that's great. Thank you. It's always good to have different perspectives, development, architecture, administrator, and with the Cassandra world, you kind of have to be all three to be good at it. You have to know
Right.
the different ins and outs. So awesome. Well, welcome, guys. Good to have you. As I said, I'm going to volunteer you guys to do a presentation in the near future.
Yeah.
Group rules, if you have a question or you have a comment, you can just ask it in the chat or just, wave your hand. And it's a community, meaning it's a discussion. It's not a presentation. DataStax is a sponsor, and we're a partner with them. We're one of the premier partners, global partners, so we just say that outright. However, anybody from our company, when we talk about DataStax, we are very objective in terms of what is the use case of Cassandra versus DataStax, and they're not the same thing. Microsoft, not Microsoft, MS and Business Analytics. If you're in DC, one of our sponsors is GW University. In-person meetings, we were holding it there, but obviously we don't do that anymore. Hopefully next year we'll be back. Local sponsors in Chicago and DC, we've got a few that we're offering venues and paying for pizza. Right now there's really no cost. So YouTube puts the bill for the video upload, so nobody has any cost right now. But, Bridgepoint, digital work order, if you guys want to put it up, as long as you show up and present every now and then, let's put your logo up here. I think that's great. Just provide content for everybody. We have a Data Community DC, as I said, is where we are incubating in the DC area. This is a Data Community DC is a nonprofit. And we have institutional sponsors that pay for the nonprofit, the operation, and some other events that we do throughout the year. Any announcements from the group? Anybody that's looking to hire anybody, anybody's looking for a job, anything coming up? We have a few announcements. Okay. There are some events. There was one yesterday, DataStax Extra, GraphQL with Gatsby. There's another talk tomorrow, Databricks and Apache Spark. And actually, I believe next week or the week after, I'll be presenting on the DataStax loudspeaker, their events, workshop series on, it's the third in a series for the event-driven toolkit. So we talked about how to build an API on top of Cassandra. The second one was how to use Kafka to make it event-driven. And the third one is going to be how to use Spark with the data that's inside Cassandra. So that's next week or the week after. I don't have the exact date. Sorry, it's not up here, but it's coming up soon. Just a reminder, all of the videos are uploaded to Cassandra.Lunch. We actually just started doing this around Cassandra.Lunch 10, so we don't have the ones before that, but I think right now there's probably 14 or 15 videos. Cassandra.Link is a site that we curate and publish on pretty much on a daily basis. This is the new Planet Cassandra. Pretty much anything that is credible and on Cassandra, it goes in here and it's searchable, so you can check it out. All right. So as I mentioned, we have been doing this for a while. I want to say back to 25 weeks ago, almost a half a year, almost 6 months. Last week, we covered Cassandra Use Cases, where we talked about essentially different customer experience platforms that, or different types of customer experience platforms that are good use cases for Cassandra. In fact, the digital work order system would probably fall under information systems somewhere. But we just talked over all the different categories of industry applications that use Cassandra, not in specifics, but generally why these features would end up being a good use case for Cassandra at global scale. And as promised, we're going to keep revisiting each of the areas of business platforms as we go along. So we'll cover customer experience on a future session, as well as obviously data and analytics and so on and so forth. All right. So I want this to be a discussion. I don't have a specific outline for today's reference architecture talk, except that I had a reference architecture presentation from before, which is on the general real-time data platform category. And what I wanted to show was that there's a common denominator where Cassandra happens to become a common denominator in these public reference architectures. And the second is that I've been collecting reference architectures in data platforms. And again, whether it's another technology like Presto or let's say Snowflake or Spark, eventually, again, Cassandra comes up in the diagram. So I've collected these off the internet. I want to show a couple of them. And this is part of my white paper that I'm working on, but I would love to get feedback or questions about these reference architectures. We do have a backlog at the end of my kind of talk. I think we'll come back around and ask people for new ideas for the backlog of presentations. Okay. So the real-time business platform architecture review, it covers more than Cassandra, but it started off as a talk on the SMAC stack, which again, not a lot of people are, except for Silicon Valley folks, use Mesos, but Spark, Akka, Cassandra, Kafka, and then instead of using Mesos, people use Kubernetes or they use Docker. Thing about it doesn't matter. We actually talked about this yesterday, which is that business platforms for mature enterprises encompass several different types of platforms. Data and analytics happens to be at the center of it, and other systems are all connected. So the old way, I mean, I wouldn't say old. It's still very relevant. Or even the current thinking is that most data comes in and the systems are synchronous. There's always some sort of delay in most enterprises for the data platform, meaning data coming in, getting processed, and then sent out to different systems. So if you can imagine in a large company, if there's a bunch of different systems, the data analytics platform is doing all that work, and it's all maybe at best on a daily basis, or maybe at best on every hour. The modern business platform is all those different types of platforms: IoT, ecosystems, APIs, customer experience, information systems, data analytics. All those systems talking to each other in real time. And if it's not that way in an organization, that's where they want to go. In general, even some of the package solutions for data platforms are starting to go into event-driven event processing. This is WSO2. But the trend is the businesses are no longer centralized; they're becoming decentralized. And as that happens, the trend is to go to essentially what a distributed ledger is. I'm not going to talk about blockchain. Blockchain is a distributed ledger, but a distributed ledger is basically a way to synchronize information across systems, one of which is Kafka. And you could say that Cassandra has a distributed ledger in the way that it does commit logs. All this eventually goes to this idea that applications need to be reactive and scalable, elastic, resilient, message-driven, and responsive, as well as extendable and maintainable. The reactive manifesto is well known. You can just Google it, but it basically talks about if you want to build an application like Google, or if you want to build an application like Uber, if you use these principles, it doesn't matter how much traffic you get, you're essentially going to be able to scale to that need while being able to add new features and remove features without impacting customers. Modern way of doing things, full speed to what we're seeing in the industry is that pretty much people who have been in the past using enterprise service buses, which was a kind of a way to do asynchronous processing, they're starting to do more lower level event-driven applications, which may or may not talk to an enterprise service bus, but they're trying to take that ESB concept and put it inside the application with microservices talking to everything. And what ends up happening is that when you have all that data across different systems getting processed, eventually you need to save it to make sure you got it. And then when you process it, you need to save it for the purpose of then serving up that data at another point. And if any of that data comes in at very, very fast speeds and it needs to be processed at fast speeds and then released at fast speed, Cassandra, as John was saying, is eventually that's the last station on the block. I mean, eventually you just have to end up using it because there's nothing else out there. Unless you pay for Cosmos DB or key spaces or even DynamoDB, you can end up doing what you need to do, or Spanner. It becomes prohibitively expensive for very, very fast writes, very, very fast reads, very, very fast analytics on top of it. And so at a high level, I'm not going to zoom in because I don't know if I can actually zoom in. No, I can't zoom in while I'm in presentation mode. But the common element in many data platforms is there is a stream layer. There are different processing engines. Doesn't have to be one processing engine. There is a data storage, which is kind of like a file system, like S3, HDFS, Azure Storage, Google FS. And then there is a fast data store. And the fast data store, a resilient fast data store, being different from something like a cache or Redis, being something that is always up and running and can withstand fault. And the reason is that, and it's also distributed, so that, let's say if you do have a data center failure, the system is actually up and running completely and the data is all synchronized on the other system. In real-time analytics, the technologies that we see is, used with all in the context are Python, Scala, Java, and Spark. You also have Flink these days. You have serverless functions that you can use for real-time processing and analytics as long as you compute and you save it somewhere. But in actual analytics, and I should have also added here something like Presto or Snowflake, but even if the data sits in S3, Cassandra, Redshift, or RDS, every now and then you have to do analytics. And real-time analytics is different. Real-time analytics is that on demand, if a user asks for information, do they get that information? Not because it was processed and it took like an hour to process it. General architecture for real-time analytics is something called the Lambda architecture. This is different from AWS Lambda. And in a Lambda architecture, you process data in both batch and speed. And the batch layer essentially reconciles the events in the speed layer so that you can say that all my calculations were actually good. You don't have to do both, but people end up having both. They have to have a batch and a speed layer. And Cassandra comes up in both the source and the sink on these processes because you can have data coming in for upstream systems, and that process needs to be updated. So people will land the data in Cassandra, process it in real time, save it back into Cassandra, and then it'll be available for serving up. Other kind of things that end up being added to real-time analytics is the event engine. When data comes in, it has to come in at a very, very fast speed. There's different ways to do this processing, materialization, or enhancement. So KSQL, Kconnect, these are really good at taking data as it comes in and just saving it somewhere or materializing it as a table. To get even more speed of processing and not be confined to the Kafka ecosystem, there are technologies built on top of Akka, which you can create clusters. You can create your own clustered applications using Akka and Alpaca to move information, and they're not connected to Kafka per se. The processing and materialization of this information is, I think, different from if we have to do enhancement or computation, meaning data comes in, we have to run some machine learning process to either retrain our model or to evaluate a test and look to do like a recommender system. That type of processing, you're not necessarily going to put in the middle of a pure processing engine that just takes data and saves it or moves it somewhere. You're going to have to need more machinery, and that's where Kafka Streams, Spark, Flink, I don't know why I have that twice, or even serverless functions can fit that need. Serverless functions could probably fit here too, but it just seems duplicative. Serverless functions are backed by event-driven systems themselves. In terms of where does the data go, right? We're using all these different technologies. Where does the data go? Well, different users will end up using different technologies. So Cassandra, Scala, DSC, these are all, Cassandra compliant. CockroachDB is Postgres compliant. Distributed SQL, TIDB is MySQL compliant distributed database, and then Galera is the same based on MariaDB, and then Yugabyte does both Postgres and Cassandra, Postgres, Cassandra, and Redis, right? Another common pattern is that people will save data to a distributed file system like S3 just to ensure that they have it before they end up putting it into Cassandra or even Kafka, so they can eventually go back. I'm going to say this, and I'll say it all the time. There's no better database in the world than Amazon S3. It is the biggest drive in the world, and it's the fastest drive in the world in terms of being able to drop something in one aspect of one region of the U.S. and pick it up in Japan. It's not really a database, it's an object store, right? You just save stuff to it and you can retrieve it, but people use it as a file system. There's also an aspect of what's called co-located data and analytics, and this is where Cassandra it shines because it's open source. So Cassandra plus Spark SQL, Cassandra plus Spark plus Solar. You can even do Cassandra plus Presto to basically have the same type of feel to it. Snowflake has its own proprietary engine to do co-located data and analytics. Same thing with Redshift. But when it comes to speed, essentially you're going to end up having to choose dependent on what you want. Do you want accuracy or do you want precision? Now, how do we bring it all together? The SMAC stack was one of the first ones, common reference architectures that came out, where using Mesos, which is a way of containerizing applications in a different way than Docker, it was used to run all of these JVM-based applications. Now, Mesos can support other types of applications as well, but this came out of Silicon Valley. And when people got wind of this, folks started to adopt different aspects of this. When people are using Kafka, they end up using Kafka to store data into Cassandra. When they use Kafka Streams, they end up using Cassandra as well. Here's Kafka Connect with DataStax Connector. It's a lot better these days, actually, where it takes data from Kafka, processes it, and saves it into Cassandra. In this case, you don't really see Cassandra, but it would end up being here. Spark users, they start using Cassandra for ingest, for getting data, and for materializing and saving data back. Here's another example of Spark being used for BI. So they'll use Spark to get data, drop it into Cassandra, then they'll use Spark SQL potentially to do queries on Cassandra, and they'll use whatever different tools that they have at their disposal to look at that information. Here's where we're using Cassandra for ingest, for the source, Kafka and Spark for processing, and then Cassandra back for serving up data. By the way, I haven't made these diagrams, right? This is just straight up Googling. You Google this stuff and you'll find it, and how people are using Kafka, Spark, and Cassandra. This is kind of like a Lambda architecture, right? We're doing some stream processing here, as well as some batch processing here, and using Cassandra for both the data lake and for business use. Here's an example of Kafka, Spark, Akka, and Cassandra. This This example, I think it's called Killer Wins. It's open source. You can actually grab it on GitHub. It shows you how to do Akka, Kafka, Cassandra, and Spark. And I was going to say Mesos, but they won't really use Mesos here. If you're curious how to do this stuff, you can learn it. It's all there. What do you get out of this? What you get out of this is if you want a global platform that is available everywhere and is available everywhere in the same way to every user around the world, then you need something like this to have Cassandra spread the data for you. You'll need to do distributed processing in different places for different users, but the data will all get synchronized with Cassandra. You'll need Kafka. Whether or not you use Kafka for the data mirroring capability of Kafka, you'll still need Kafka to do that volume of information. And then Akka is not as commonly used. I think high-speed systems like trading systems, they use Akka nowadays instead of C++. Very few people will end up using Akka. I mean, you kind of have to be Twitter or Uber or one of those guys, one of those giants to end up using Akka, or you have to be like a stock trading company. It's not that difficult to use. Akka is actually just a way to do Scala or Java. There are other frameworks in C#. There's even an Akka.NET. There's also actor frameworks in Python. And all an Akka system or an actor-based system does is a process comes up, it takes a message, not like a Kafka message, just any event, processes it, and sends it to somebody else. So it allows people to build very, very scalable systems. So if you have millions of these processes running, and these millions of processes have to save data somewhere or retrieve data from somewhere, they need a scalable system like Cassandra. Otherwise, they're going to end up having silos, right? SQL Server here, Redis here, MySQL here. With Cassandra, it allows the whole system to store data in a common infrastructure. And this is where I think Cassandra is misunderstood sometimes as a pure database. Cassandra is actually a data platform. It is a set of microservices that basically serves up your table as a microservice that is available infinitely as long as you keep adding hardware. New things, as I said, Alpaca is fairly new. There's another technology called Apache Pulsar, which compares to Kafka. It has some nice features which are not available in Kafka, but you can use it with Cassandra. So kind of like coming back in and closing this conversation for a second, you know, here are the major players in real-time components, and you've seen their logos in a lot of places, but there's no one right solution. I think Cassandra plays a big part because it's fairly easy to get started, but sometimes people have a need to go faster with less hardware, and then they may go into Scala, which is written in C++. Now, at the same time, there's some drawbacks. If you have a very, very big Cassandra node, you can't add and remove nodes as fast because it has to stream data, but it's a use case for some people. Yugabyte does CQL, Postgres, and Redis on one platform. You know, and people use different technologies, and you just have to ask yourself, do I need the fastest data in and fastest data out? And do I need this data everywhere around the world? Do I need this data to be always fault tolerant? If you say yes to every one of those things, then you basically end up using Cassandra, or you pay for the price of Cosmos, Dynamo, Cloud Spanner, because otherwise you're going to have to end up doing the DevOps for all this stuff yourself. Spark is probably the most popular in terms of data processing with Cassandra, just because it's been around even well before Cassandra. And in terms of the queues or the message streams, again, Kinesis is a close second, but again, Kafka ends up being the most common one that people end up using. All right, I'm going to pause because we're at like 12:40, and maybe we talk about some of these things before I show some other pictures. Any questions about what we just talked about? And I know there was a lot. There's a lot of information there, but would love to see if anybody has seen this in their experience, or you know, has seen any drawbacks of this type of architecture. Okay. So as I promised, I do have diagrams that I want to show other systems that are different platforms, completely different vendors, and how they end up using Cassandra. So, so if you're not familiar with Stradio, basically they run on top of Spark, but they offer some kind of like bells and whistles, essentially, so that you can do. It's a package platform for Spark. I guess it's not that much necessarily different from Qubole or Databricks, but Stradio is one of the. They've been around. I wouldn't say they're popular, but they've been around. Here's another architecture diagram for Stradio. So what they end up doing with Stradio is that they have multiple data sources. So Cassandra ends up being one of those places. They have Spark here. They have some, I don't know how to say, proprietary way of materializing information. And it's again, Cassandra ends up being a part of the stack. Here's another diagram from Stradio. Events get processed using Spark and Kafka, and then they get stored in Cassandra. Sometimes people can directly get that data from Cassandra, or they use it using Spark SQL. There's another technology called Starburst. So Starburst is it's a commercial vendor for Presto. Presto is a technology out of Facebook. We actually have a couple of videos on it. Presto essentially virtualizes your data. And it could be from any of these different sources, NoSQL, RDBMS, EMR, object storage, and provides a common SQL layer, Hive-compliant SQL layer to get that information that then you can look at in your BI tools. So Cassandra happens to be one of the well-supported, it was one of the first sources for Presto as well. You don't need Spark or Kafka to use Presto with Cassandra. The way that Presto works, you have these kind of like coordinators and planners and workers, and it gets the data in real time for you. So it's actually executing queries, doing some joins, doing some analytics for you in these workers. It's not instantaneous. So if you want to do a join on Cassandra, you could do that with Presto, but it's going to have a little layer and it's going to have a bit of a latency if you don't have a good star schema. There's another picture where we got Cassandra, got even Kafka here, different BI tools, and after a while it gets old. I mean, basically it's the same thing, right? It's just different people using Presto in different ways, basically to access information and retrieve it from various different sources. I like this one because it explains the different major technologies that people use and how they can be used together. Databricks, when they come and sell software, they just want you to use Databricks. Or, when somebody comes with Snowflake, they just want you to use Snowflake. And the reality is that in any mature company, you're not going to have one solution to fit everything. And I like the diagrams like this that say, yeah, you can bring that too. That's why I think Presto is one of my favorite tools, is because and Spark, Presto and Spark and Kafka, because they work with any data store. It doesn't really matter which one. Here's Presto on AWS. Here's Presto on another system called Alexio. And then I have one more set of pictures. I don't know why I don't have this. But I do have some Snowflake diagrams. And Snowflake is a proprietary data warehousing technology, but people use Cassandra to get data into Snowflake and to get data out of Snowflake for basically fast retrieval later. Snowflake's a great engine. You don't necessarily want millions of people hitting that data store. So people will have their data that gets processed and put into your data warehouse, and then that data can be exported out to a Cassandra database for fast retrieval. Here's an example where data comes in, and then Spark is used to retrieve that data and send it somewhere else. Another pretty little picture of Snowflake. Let's see if we can identify. So I don't see Cassandra here, but basically data comes in, it's saved in S3. Snowflake is then used to then process information, and then data can be sent out to visualization or Spark. I would potentially put Cassandra here or maybe here after Snowflake. And then it's kind of repetitive. So we talked about these two main things, which is, what does a real-time data platform look like these days? And then some reference architectures from third-party companies that show Cassandra. What I wanted you guys to get out of it was that it's not about Cassandra. It's about how Cassandra is used by different users in different architectures, in different, even by different third-party technologies, because of what it's good at. And other technologies are used for what they're good at. Right? It's not an end-all, be-all technology. It's definitely got a niche use case. So that's all I had for today. If you guys wanted to discuss anything else, so if you have any questions, we can talk about it. Otherwise, we can call it a wrap. Okay. So next week, we can either talk about one of these, or we can do one of these, or John, if you guys can present on how you guys use Cassandra, that'd be great. John or Hussein?
Yeah, after hearing all of the possible things that you guys could do with Cassandra, I'll be honest with you guys, we've been living in a bubble with how we're doing things, and a lot of the stuff that you talked about have me and Hussein chatting and thinking about how we should change what we're doing. Cassandra is always still going to be in the back. We're actually using Ignite, something that was not mentioned. But we're now questioning Ignite and Rabbit. We're now questioning the idea of using Rabbit MQ and instead use Kafka for it, and then take advantage of everything else that Kafka has on top of that.
Yeah, Kafka has so many benefits, even if you just use Kafka Connect. Because if you get data into Kafka, you can pull it from Spark, you can pull it with Kafka Connect, which will then just save it for you in whatever place you want. You can index it at the same time, you could save it into Cassandra, you could even put it into a SQL Server database, for analytics purposes. So, look, it's your knowledge of what you bring to the table. There's probably somebody there right now that is thinking about this transformation. And where you have made your transformation, where you guys are right now, is probably more accessible to those folks than what we just talked about, right? So everybody's knowledge is always relevant. Your knowledge is definitely relevant for the people that are just like, oh, I don't know how to do this. We have a customer right now that is in the middle of transforming their logistics software to Cassandra. They're using DataStax, but they're using graph technology, and they're struggling with a lot of these things, right? They're using Kubernetes now, they're using Kafka, they're using this brand new technology, and they're struggling because this is their struggle. But if you happen to maybe tell a story, like what you just started with, right? You don't have to necessarily do a technical presentation. Just being able to talk about your story of how you took an application, broke it down, made the probably monumental steps to get to where you're at. That's a great case for the public consumption, because that's what people ask about. Who's done this before, right? And that's why I kind of brought these up. So, maybe not next week, maybe the week after. I'd love to have you guys talk, and it could be completely informal. I mean, you see how I just did this. It doesn't have to be formal at all. You could just talk about it, and if you have the digital whiteboard stuff, you could even do it on a digital whiteboard. It doesn't really matter. So, I'd love to have you guys talk about something about how you guys use Cassandra.
Yeah, let's stay in touch. Let's see how we can make that happen.
Yeah, if you want, just drop your email in the chat, and Akwi can, because I don't know if we can get your email from either Meetup or from Zoom. So just drop your email in here. That'd be great. The topic for next week, hoping John or Hussein can give a presentation. I'm going to just put that in Cassandra Journey for Digital Work Order. But if
at least push for the week after.
Okay, that's fine. That's cool. So we got a couple of popular topics that keep surfacing up there. One is Cassandra and machine learning. One is a second talk of Cassandra on Kubernetes. We've done a talk about that earlier. Another is Cassandra for data analytics, data analysis and data science. More specifically, the job as a data analyst, not necessarily the technical aspect of it. Data modeling is always new for everybody. We can continue talking about data modeling. So any votes for any of these up here? Or do you guys want to add anything to the backlog?
Well, you mentioned you guys did a Docker topic earlier. Is that recorded somewhere?
Cassandra, well, no, we have not. We just generally.
Oh, you have not. Okay.
Cassandra. Yeah, we generally talk about Cassandra and Kubernetes, but I'm gonna say that like it's not been exhausted, and this is a very deep subject. So, in fact, I have a blog post that I have to write for the Cassandra.Apache.org website that basically brings together the canonical way of doing, Cassandra on Docker and Cassandra on Kubernetes. So maybe I will put that a little bit later. But yeah, that's exactly that we're going to end up doing in the next couple of weeks. Cassandra on Docker and then Cassandra on Kubernetes.
Okay. Yeah, I think that's one of the big things me and John have been thinking about when we're trying to scale. Because right now, our Cassandra instances are all on bare metal, and we're like, is it worth putting on Docker with how Docker does all the layering? And is there like benefits, pros and cons, and so on? So it'd be good to have a discussion on that at some point.
You know what, I think related to what you just talked about from what your actual pain point is, I would say Cassandra scale options on bare metal, virtual machines, and containers. Because all of them have a place. I think the best of both worlds is virtual machines. And I have a reference architecture where it's using both virtual machines and containers. So there's a data center that can scale up and down, and then there's a data center in virtual machines that stays, right? You can also do hybrid cloud, which is having bare metal for like not necessarily your transactions, but just like this is your backup copy, and then you have virtual machines for. So I think this is a very deep topic, right? So we can also talk about hybrid. Okay, cool. I mean, I think we can do that topic next week. I've got a couple of diagrams for this actually ready to go too. Cool, awesome. Cool. Anyone else? Any other questions, or do you guys have anything that you want to add to this? No. Alrighty. Well, guys, we have 6 minutes left on the hour. I'm going to give you guys that time back. Thanks for joining. We'll be here same time, same place, 11 a.m. Central, noon Eastern. And as always, this stuff is recorded and available on YouTube. So thanks, everybody. Talk to you guys soon.
Thanks.
Thanks, man.